Okay, so in this particular topic, we're going to talk about and explore this topic called the difference quotient, and which is basically there's another term for it in calculus, but this is the foundation of mathematics. This is the foundation of calculus. So if we understand this, we understand calculus. Okay? So basically, I have this graph here. And in order to make a line, we need 2 points. So I have the point 1, 3, and 2, 7. And we can find the slope of this line by using this little formula y2 minus y1 over x2 minus x1. So remember, another way to say slope is rise over run. So basically, we're using that rise over run and using this formula to find that slope. So we'll label this first point x1, y1, and we'll label the second point x2, y2. Now, does it matter which one is x1, y1, or x2, y2? No, it doesn't matter because in the end, you'll get the same result. Okay? So when we plug in this information, all right, so we'll have this is equal to 7 minus, not too big, 7 minus 3 over 2 minus 1, which gives us 4 over 1, which is 4. So the slope in this case, it or m is equal to 4. So that's the slope. Okay. Another way to think about that is the rate of change, right? Or in this case, the average rate of change. Okay? The average rate of change. So, but life is not all about straight lines, right? Life, there's a bunch of curveballs and different paths for everybody. Okay? So, to use this formula, right? This little formula is a straight line, but what happens when we have something that is not straight, called nonlinear? Okay? Nonlinear just means not straight. Non Nonlinear just means not straight. Not straight. So what do we use to find the rate of change, the average rate of change when it's something is not straight, like this graph here? Okay. Actually, in particular, I want to find out what is the rate, okay, at one particular point. How do I do that? So I want to find out, say, at this first point here. So, for example, you know, um, the mall here, the outlet mall is not far from where the campus is. So let's say as I'm driving to the outlet mall, at what point, so that say at 3:01 p.m., what is my instantaneous speed? Okay? How fast am I going as I pass the outlet mall at 3:01 p.m.? How fast was I going? Right? So the difference here between the instantaneous and the average rate of speed. So let's write that down. So instantaneous versus the average rate of speed. Okay. So what we're going to do is instantaneous, it means at one particular point. Average means 2 points. And so we're going to use our average speed to find out the instantaneous speed. Okay? What do I mean by that? So let's look at this graph here. So in order to find the average speed, right, we would pick 2 points here and we would take the average. So let's draw our line. Let me use a different line here or a different color. So I would find, I would draw this line here. But again, I want to find out at this point, What was my speed? What was my instantaneous speed at this particular point? Well, again, I can pick 2 points on this nonlinear graph, and I can give you an estimate. But again, this estimate is pretty far off, right? So what can I do? Well, maybe I can bring that point here a little bit closer. So maybe I plot it right here. Okay? I plot it right there. So that means then I can have, I can draw another line. Okay? I can draw another line here. Try that one more time. There we go. Okay. Draw another line, and then I have another point. Okay. So I'm a little bit closer, but again, it's still pretty far off because again, I want to find out what my instantaneous speed at this particular point. Okay. So as you probably would guess, I would just kind of keep doing this, right? I'll just bring another point, all right, and then draw another line, bring another point, 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 until I get really, really, really close that it's almost on top of that other point, right? So I keep drawing these lines, okay? I keep doing it over and over and over, right? Infinite amount of times, so I'm so close to it that you can't even distinguish between that there's actually 2 points. They just look like 1 point. Okay? So so in this case, this is what's going to lead us into this formula. And it's called the difference quotient in pre-calculus. So this here, this is going to be my x, and this over here, this is going to be my uh, in this case, so let's say that this was x1 that we had here, right? This was x1, the first point, and this was x2 on the second point. So we're going to relabel those as x, and this is going to be x plus h. Okay? This is going to be x plus h. All right? Now, as I mentioned before, so we have y1 and y2. So this was y1, right? So this was x1, this is x2, this is y1, this is y2. So remember, another way to write y, right? Another way to write y is f of x, okay? So in this case, we're going to label this one here. Instead of y, a little bit closer up here, instead of y, we're going to label that as f of x, okay? And then up here, instead of y2, all right, we're going to have f of x plus h. Okay. All right. I'm a little bit up. It doesn't matter. If I draw it down, I'm going to run into that graph there. Okay. All right. So again, this is my y1. So let me just make it this clear. This is my y1. Here is my y2. Okay. Okay. So if I were to write the slope formula again, I have m is equal to y2 minus y1. Again, what I'm trying to do here is derive the difference quotient formula, x2 minus x1. Okay, so our y2 is the up here, the f of x plus h, and our y1 is f of x. Okay, and then our x2 is what? X plus h, and our x1 is x. Okay. Now notice in the bottom, we have an x here and then a minus x. So the x's are going to go away, right? They're going to cancel. So this x is going to cancel with that x. So then let's simplify this. So in this case, we're going to get f of x plus h minus f of x all over h. Now, this formula is missing one important part, and that is the limit. Okay, so normally you have this other notation, it's represented as lim, the limit as h approaches 0. Right? Again, we don't write that here in pre-calculus, but we do write it in calculus. So, but there's a big part here that's missing. So this here is called the difference quotient, right? That's called the difference quotient. Okay. And with the limit here, this it's called the derivative or the definition of the derivative. But again, that's beyond what we're talking about right now. So, but anyway, but this part I want to do point out because this is important and what this h approaches 0 means. But that's what I'm going to talk about. This h approaches 0. H is going to 0. What is this part indicating? What is it saying? Well, it's basically what we've been talking about. Okay? So, um, as we get closer, so we had the 2 points originally, and again, we want to find out what the instantaneous speed at this particular point. So we draw more points closer and closer to that instantaneous speed. So that's what this is. The limit as h approaches 0 is telling us the distance between the 2 points is basically 0. That's what it is saying. The distance between those 2 points are basically 0. Okay? But there's still, you know, a difference between them, but it's so small, it's hard to tell. Okay? But that's what they're saying. The distance between them is basically 0. All right? And that's important. That's basically the concept of limits is getting closer and closer to a particular value. Okay? All right. So anyway, um, this is important as we solve this in calc, but right now it's kind of just a blur in pre-calc. So, but yes, this part here is vital. I'm going to take it out right now because we're focusing on the difference quotient. This is our formula we're going to be using to solve these next set of problems. Okay. And let me just pause here for a second. So let's think about what the word difference quotient means. The difference means subtracting, right? Difference means subtracting, and quotient means division. So again, difference means subtracting, I'm subtracting it, and quotient means I'm dividing. That's what this formula is. We're subtracting two functions or two particular points, and then we're taking the division, the quotient, right? So that's what the difference quotient entails, is this whole concept. I'm getting closer and closer to another value where I find my instantaneous speed at that particular point. Or in other words, the concept of the limit or the derivative in calculus. All right, so again, I want to use the difference quotient to solve this problem. But before we do that, we have to understand what this is saying. So we have f of x equals 2x. So if I put in 2 in there, that's going to give me 2 times 2, which is 4. If I plugged in 3 in for x, I'll get 2 times 3, which is 6. If I plugged in a happy smile there, I'll get 2 happy smiles. Okay? So whatever you put in for x, that's what's going to spit out. So if I have f of x plus h, that's going to be 2 times x plus h. Okay? So whatever I plug in for x, that's what's going to be spitting out. All right? So I have f of x equals 6x plus 1, and I want to use a difference quotient. So the difference quotient is f of x plus h minus f of x divided by h. All right, that's an h right there. So f of x plus h minus f of x divided by h. So we need to set up in this format. Well, I know f of x. F of x is 6x plus 1. What I need is f of x plus h. Okay? What I need is f of x plus h. So let me rewrite that. Okay? So let me pause. Okay? Whatever is in my parentheses, that's what I plug in for x. So again, in this case, I had x plus h. So I'm going to plug that in there, right? So every time I see an x, I'm going to plug in x plus h. So here I'm going to have 6 times x plus h plus 1. Okay? Remember that. So now I have all the information that I need. F of x plus h minus f of x. So f of x plus h is 6 times x plus h plus 1 minus f of x, which is 6x plus 1 divided by h. And then I just simplify. Okay? So I'm going to distribute that 6. So I'm going to get 6x plus 6h. Let me rewrite that. Plus 1, and then I'm going to distribute that -1, which is minus 6x minus 1 divided by h. And what's my goal here? My goal when I do the difference quotient is to eliminate that h. Eliminate the h in the denominator. Okay? That's my goal, is to limit this particular h in the denominator. And see if we can do that. So um, as you notice here, if we do this correctly, things start canceling out. So notice here the 6x cancels out, the 1's cancels out. So that I'm left with 6h over h. Okay? And what happens next? Well, what happens? H's will also cancel out, so leaving me with 6. So my question is, what does this mean? What is the difference quotient? The difference quotient is just another way of finding the slope. Okay? And I call it the slope generator. And you'll understand what that means later on. But in this case, the difference quotient is just a fancy way of saying what is the slope. Okay? So if we look back in our original equation, this one right here, we had f of x equals 6x plus 1, right? So if I were to write the general, it would be y is equal to mx plus b. And m is what? M is the slope, right? M is the slope. So in this case, if we look at our equation, f of x equals 6x plus 1, what is the slope? 6. 6 is the slope right there. That's the slope. And what did we get here? 6, right? It's not that always that easy, but I'm trying to demonstrate to you that the difference quotient is just a fancy way of calculating or figuring out what that slope is. Of course, it's more in depth in that, but in the general idea, that's what it's doing.